And a warm welcome back to Northampton College. I'm James. Today we're going to look at electrical part 2. This is episode 5. So we're going to be working with our temperature and oil pressure gauges today, and we're going to look at some theory behind the science, and then we're going to show a little demonstration of NTC, that's negative temperature coefficient, and then that's going to line us up for what we're going to do later on. Oil pressure gauge and our coolant temperature sensor gauge, and there's a common denominator in both of them, and it's this here, this variable resistor. So what we've got to remember is there's our battery voltage. So one side of our battery we've got this high pressure, okay, that's in this live element. We've got 12 volts there, we've got 0 volts there. So one side of the battery is high pressure, the other side is low pressure. This high pressure is always trying to get to the low pressure. So the live, the positive, will always try to get to the negative. Now, because the battery is high resistance, the only thing it can do is leave the battery and go through a circuit and get to negative that way. So this is how automotive electrics works. Now that could be a motor, but in this case we're just going to look at a gauge. Now I've drawn there a coolant temperature gauge. So you can see the C there for cold, the H for hot, and it starts by going through one resistor. This is essentially the inside of our gauge. That's what we don't see, that's in the back. Now you see there's a fixed resistor, and you see after the gauge there's a variable resistor. The variable resistor is the coolant temperature sensor. This is the gauge and this is a sensor that's on the engine. So this has two purposes. One, it helps create a voltage dividing circuit, which we're going to look at in later electrical courses. And its second function is if the wiring going from the gauge to the sensor on the engine gets trapped, goes to ground, like that, gets a short circuit, it means that it's kind of controlled and it's safe, because this fixed resistor won't allow all this wiring to short out. It just pulls it down enough and protects the wiring in front of this resistor. So that's its first function, but let's look at its second function. So the second function now is that we can operate this voltage dividing circuit. So as it runs through the back of the gauge, and let's be clear here, from a college perspective, this is just showing you a very, very fundamental version of a coolant temperature sensor gauge. This has all been replaced now with sophisticated electronics, but to understand the electronics, you've got to go back to basics. So this is very basic. We have a winding in the back of our gauge. So as the voltage, high pressure voltage, leaves the battery, goes through the ignition switch, all the fuses into the dash panel, then it goes to our gauge, it's still trying to get to ground. So as it goes through this winding, just like our alternator we spoke about in the last episode, it's going to leave the gauge and then try to go to ground for a variable resistor. Now, this is an NTC coolant temperature sensor, which means that when you apply heat to it, the resistance falls, so the current flow increases, which means that when it's cold, your resistance is high, so there's very little current flow. So this is what's happening. It's like a tap. When it's cold, this tap is just trickling little droplets of water. It's just allowing little bits of electricity through, going to ground, which means that the current going through this winding is very low. So the magnetic field that it creates, just like in our rotor in the alternator, is also very low. So therefore, the back end of this needle that we're looking at there on our gauge, behind the dash there's like a metal element, and the back end of that because it's metal and it's being attracted to this magnetic field, it's only going to rise a little bit. So that's when it's cold. Now when it's hot and we apply heat to this NTC coolant temperature sensor, the resistance value now starts to fall, so the current flow will increase. So this is like loosening our tap, turning the tap on more and more and more, and allowing this current flow now to come to ground. Now, as you get an increased current flow through our NTC coolant temp sensor, the magnetic field on the back of this gauge increases, and now it pulls the needle up higher. So that's why, as the engine heats up, the resistance of the coolant temp sensor falls, the current flow increases. So as it increases and you get extra magnetic fields on this winding here, it's going to pull the needle up closer and closer to hot. So that's how that movement of that needle correlates with the resistance value of this NTC coolant temp sensor changing. So continuing from what we've just spoken about in the classroom, what we need to do now to start with is always measure your battery voltage. So let's do that. Okay, as you can see there, we've got 12.5 volts. Ideal voltage would be anywhere like that. 12.6 is a good number too. So we need to know what we're starting with. So if there is any electrical problems, we've got a good starting point. There's no point just going straight into in-depth electrical testing, but you don't know what the battery voltage is. So always start there. So that's good. So we spoke earlier about the voltage going through the gauge first. Now the gauge is essentially a resistor, so this becomes a voltage dividing circuit. We've got a resistor at the gauge, and we've got a variable resistor down in the guise of a coolant temp sensor. Put the temperature sensor wire on. That goes over the top there, coming down. I've got to join that into the wiring harness. Wiring up my oil pressure switch so the gauge on the dash, the Scania one, works. I just didn't want the other one. And the wiring for that is somewhere down there, down that tube there. So that's going to go nicely though, actually. Okay, so when you know you've got good battery voltage, now we're going to check this NTC coolant temperature sensor. Now you'll see on a lot of this era of cars, this is just a training car, guys, so nothing special, and of course you have to accept the training cars are all going to fall apart with the students breaking them. So this has got two NTC sensors. The reason it's got two is because one, which is connected to my wires there, is for the EFI system, and one is for the gauge. So when I see two, it's a little indication that the car is pre-network system or pre-CAN bus. So there's just a little added piece of information there. So what we're going to do is prove that as the engine warms up, the voltage will fall. Okay, so this one here is your fuel injection NTC sensor. So we're going to just start the vehicle up, and then we're going to test the voltage. But let's test it first. And that's showing around 1.7 volts. Now on an EFI system, they're generally anywhere between 4.5 and 0.5 volt range. But what we're trying to prove here, just for purpose of learning, that an NTC sensor will open up like a tap when it soaks up heat. So as it absorbs heat, the resistance value is falling, so therefore the current flow is increasing. So as the engine warms up, that number, that 1.7 volts, will fall. Okay, and you can almost match your temperature gauge in the car to it. So it's another way of checking your coolant temp sensor. Let me start the car up. So we had 1.7 volts. Now I'm going to reconnect it. You can actually see it falling as we're speaking. So this is NTC live. As the sensor resistor element soaks up the heat from the engine, then the resistance value of the sensor itself falls, so therefore the current flow going to that sensor will increase going to ground, and that shows itself by the voltage I'm reading there. So we started at 1.7 volts and you can just see it falling. So guys, get yourself a multimeter, get yourself a cheap scan tool. You don't have to buy all this expert equipment. You can test so much with your own car that a scan tool really will just end up giving you fault codes unless you understand all the live data. So this is just a very cheap multimeter for the college, and we have a very cheap scan tool that we can still understand if a sensor's working or not. So we started again guys, 1.7 volts. Now it's down to 1.39, it's falling. So with our gauges then, we've got a coolant temperature gauge and we've got an oil pressure gauge. So straight away, we've decided that we've got an oil pressure sensor and not a switch. A switch is very binary. It's either on or off. That would be the scenario if we was just putting an oil pressure warning light out. It'd just be either on or off. But we've got more than that. We've got an oil pressure gauge. So it stands to reason that we need a variable resistor, a varied sensor. So they're the sort of systems that we're looking at today. So in this final video, what you can see there is just our Scania starting up, and we're checking all our gauges. You can see the oil pressure works. You can see the air gauges work from tanks 1 and 2, and you'll notice there our coolant temperature, that's working too. Obviously we've just started the truck up, so think back to our NTC sensor. You've got a sensor that's got very high resistance when it's cold, so therefore not much current flow through the gauge, so therefore the needle is pointing down towards the C, the cold part. As that heats up, of course, the heat from the engine is going to soak into this NTC coolant temperature sensor. Then the resistance value will fall, so you get more current flow through the gauge, and then the needle will rise and move towards the center of the gauge. So here we are again, end of episode 5. It goes quick, doesn't it? Really enjoying ourselves doing these YouTube videos. We're learning all the time. We're getting better and better at editing, and let's get some more subscribers. Give us a like, share the video, and help us build the channel. So looking forward to the next one, guys, and remember, Team 143, let's do this.